everybody, it's Tyler here at the Wisconsin Regional checking in team number 706 Cyberhawks. This team, very unique robot that I love to show you here on Behind the Bumpers. And to help me talk more about it, I have Sarah, Owen, and Aiden. And interesting, I'm told the car wash intake, we'll talk more about that. The shooter is very unique as well, kind of a plunger type shooter that brings it in and out. The climber has been very consistent in their second event here. Let's talk more about it coming up on Behind the Bumpers. Your destination for first content, updates, and gaming.
Welcome to the fun.
First Updates Now is supported by Stryker Careers. Apply the skills you gained as a first student or mentor and help change the world at Stryker. Stryker is the top career choice for many of those in FIRST because of their commitment to innovation and saving lives. Learn more about the incredible culture at Stryker and view their thousands of positions available around the world at careers.stryker.com. Sarah, we're going to talk about this intake here. I'm told there's a little bit of car wash action, like legit car wash action, not just called that, but it's actually from a car wash. So talk to me more about your general intake and any concepts that you come up with throughout the season, that sort of thing.
Yeah, for sure. So our intake, these were actually donated to us by an actual car wash. That's why we call it the car wash intake.
Sure.
It rotates on the same axis as this as well. And it creates a vacuum to almost suck in the balls so we can get it in as fast as possible.
So when you're looking at this type of drop-down intake, like, how did you come up with this concept? Like, what made you go this route? And did you have any other like ideas that maybe you didn't go with?
First, our ideas is we had a different sort of addition to it. Is they were rubber, but that didn't really work, and they would keep snapping off. So then someone went to a car wash, and we thought they were really nice. So that's what we did.
So you just like went up and asked the car wash, said, "Hey, can I have some of your material for this?" Or like,
yeah, we just
cool,
emailed
go
them.
ahead.
Yeah, we just.
You want to give a shout out to the car wash?
I think it was Mark 7, right? Yeah.
All right, well, hey, let's get some extra sponsorship crowd, maybe free car washes later, who knows, right?
Yeah, for sure.
On your intake here, talk to me about just kind of how this transitions into your shooter a little bit, like, because it's very compact on your robot.
Yeah, for sure. So the ball comes up under here and gets into there, and then the shooter will come down, and these two will separate, and it will get on top of this, go up, and then shoot for us.
Well, let's bring in that piece of cargo. We'll show that, and then we're going to bring in Owen to talk more about the actual shooter. So can we actually intake the cargo?
Yeah, intake.
It sounds like a car wash too, actually. For sure. All right, so Owen, let's go into your shooter here. I'd love to hear a couple things. Obviously, the way you're shooting is very unique as well too, using pneumatics for that, it looks like. But talk to me about like the general concept of actually having that two-stage arm, essentially, where you're gonna intake and then pivot and then shoot. Why did you choose to go that route versus a lot of the other robots we've seen?
All right. So the one thing that we wanted to have was to have as the least like complex robot as possible. So instead of having to have a shoot like in the years past, where we've had that fail and get caught, we decided we wanted it all in one piece, so that we're able to pick up the ball here and just go straight up without having to have more motors, more parts that are moving, and possibilities to break. And then it goes straight into the shooter. It doesn't have to have a flywheels or anything to spin up, so it's ready just to go right here, which means we can then put our second ball here to hold.
So you're actually holding the second ball as this one comes up, and then you grab the next one, right?
Yes, the second one will sit right there.
And I think one of the things that surprised me is actually how quick that process is on your team. Other teams have seen do it. It's shoot, takes a few seconds, and then goes again. You're able to get your couple out in just about a couple seconds, I think, right?
Yeah. Yes. The reason that we're able to do that so quickly is that we have an actual Auton code to say that. So we push the button, say, shoot once. It'll come down, it'll take it and shoot it, and then here, it'll go down. All right. And then we have a two-ball shoot. So if we're holding two balls, we shoot it, comes down immediately as fast as it can with the code so we don't have any human error in it, which has gotten rid of very many problems. Speeds everything up.
And then from the actual way that you're shooting, where you're just like taking cinematics and just pushing it forward, it looks like you're able to shoot from most areas of the field actually pretty well. So talk to me about just the general pneumatics and the plumbing, and that's a lot of air you essentially got to use throughout a match, right? So how are you making sure you're getting enough? And then how'd you figure out like how much force you need to shoot from where you need to shoot from?
Yeah, that's actually the amount of force that we need to use has been a long trial. We took weeks and weeks to figure that out, to tune it in, to get the proper amount of force that we need, amount of air, to get it to actually shoot up into the high goal. So to make sure we have enough air, we start out with having the compressor that will then that then puts it into a 120 psi tank right here, which then feeds into these two 60 psi ones, because we're legally only allowed to use 60 psi activating. So then we have these solenoids that activate, and it's able to put the air into these two pistons that run on the arm behind it. One cool thing about it is that we don't just put the air, we put the air into the pistons and then we lock it with this third one, which then allows us to build up that, for when you activate the other ones, it builds up the full 60 psi in the pistons right away, so that when you release it, it's able to use all 60 psi to push that it's already built up in the pistons to shoot it as hard as possible, instead of having to wait for the pressure and the air to go through the tubing and the small solenoids and openings throughout it. So it's already there.
Well, let's start to wrap up on your robot, talk about your climber a little bit. Speaking about automation, I got some cool automation with your climber as well, so I'd love to hear about the climber, and then if you can run me through some of the climb sequence as well too.
So while we were climbing, our main priority this year was to hit the traversal bar. So we made sure that we had two hooks that could rotate. These can rotate forward and backwards so that they can catch the bars. And we have two extending bars. Each of them are controlled by brushless motors, so that gives us position control on each of them. When we were practicing, we realized that our climb needed to be fully autonomous in order to completely meet the time requirement that we wanted. So what we did is we wrote a timing sequence that uses our position control to consistently get up to the high bar, or the traversal bar, in 20 seconds. I can run that really quick if you'd like. So
yeah, let's check out the actual sequence for it.
The driver presses one button to bring the arms down and get ready to climb. And then once we get into the climbing setup, we then extend our hooks and go up. We can then drive forward, hang on the mid bar, and then with a single button, we can press it and it'll run the remainder of the climb sequence.
And you said about 20 seconds do the whole climb. When you're looking at analyzing the game, where does the 20 seconds come from? Like from your cost analysis, so like if you're shooting cargo or climbing, how did 20 seconds come up?
20 seconds, we could shoot about 4 to 5 or 4 balls tops. So we figured even if all 4 of those ended up in the high goal, that would be 8 points versus a 15-point traversal climb. So as long as our climb was under roughly 45 seconds, it made complete sense to go for the traversal climb every match.
Well, 706 Cyberhawks, a team that I saw last week at CIR. I was really impressed by that. Glad we got to talk to you here to show off some of the unique, cool features of your robot. Wish you best of luck here at Wisconsin, and of course, moving forward as well. Thanks a lot for taking the time.
Thank you.
Thanks to Stryker Careers for their support in this video. Apply the skills you gained as a first student or mentor and help change the world at Stryker. Stryker is a top career choice for many of those in FIRST because of their commitment to innovation and saving lives. Learn more about the incredible culture at Stryker and view their thousands of positions available around the world at careers.stryker.com. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.